Hey, what's up? Advent Code 2024, day 10. So, again, sorry, I'm late on this one again here. But yeah, still going along, still trying to do my best here. This one was a fun one. It's like already just from reading it, I knew it was going to be some kind of depth first search or breadth first search kind of solution that we're gonna have to do. But yeah, so let's just get into it. The problem is basically that you're given this topographic map. So this is the input here. And what each number, so it's just a matrix, and what each number represents here is the elevation. So this would be a height of 0, and this would be a height of 1, this would be a height of 2, this would be a height of 3, right? And 0 to 2. So the point is that you can traverse through this map here, but only in through jumps of 1. So, and also you can only go up, down, left, right. You can't go diagonally. But say for example, let's see. So if you went to this one, and then so you always got to start at 0, which is the lowest, and then if you say jump to here to the next step here at 1, so that's valid. So you can go there. But you wouldn't be able to go to this one here because that's too great of a change in altitude, right? But you could jump to 2 because that's only a difference of 1. And so those are the basic rules. And then what you're able to do from there, or the goal is to get to 9. And so the setup is basically that this is a trailhead, like this is like a map of some trail, like that you could hike, and you want to give each of these starting points a score of how many ways are there to get to the top of this topographic map, and the top will always just be a 9. So in this example here, this starting point, this trailhead, it can get to this peak here of 9 in 2 different paths. So it's given a score of 2. And then there can be multiple trailheads that start at 0. And so this one contains 2, and the top one, there's only 1 because you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 4, 6, 7, 8, 9 this way. And so oh, I'm sorry, I'm looking at the wrong one. So this one has a scale of 4 here. Sorry, I was reading the wrong thing. This one you could go to 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 1 right there, another one right there, another right there, 3, 5, 6, 7, 8, 9. So that's 4. And then, so on and so forth. For example, this one has 2 trailheads where you could start at. And so this one only has a score of 1, 0, 1, 2, 3, 4, 5, 6, 7. Okay, so also you can only go up. You can't go down and keep going. You can only continually gradually go up. So that's why this one only has 1, because you can't go from this one to here. The only next valid move would be to here because it's 1 higher. I should have clarified that. So this one has a score of 1, but this one has a score of 2 because it could either go this way to 9 or this way to this different 9. And so in this example one here, which I've just hard coded into our code, into our script over here, there's 9 trailheads, and each one has a score of 5, 6, 5, yada yada yada, and the sum of them of each of the trailheads is 36. So let's look at my code here. So the real meat of this that's going to happen is in this search map function. But basically, this is our main here, and so I'm just doing for every trailhead that we look at, we're going to add whatever the score. I should have called this like, trailhead, like get trailhead score, and then add that to our total, and that'll give us our answer. So, okay, let's look at the search map function here that we came up with. So it takes in a tuple of positions, just like an XY position on that matrix. And then I get an array of next steps. So this function, all it does is get us like all the valid possible steps that we can go from this position. And then for every position there, if that step is in our list of sort of, terminal points of where the trail can end, I have a function for that just gets the list of all the trails, that gets the ending point for all the trails. And if it's something that we haven't already visited before, we're going to count 1 and then add that step to our visit, because we don't want to go over it again. And then otherwise, we're going to do this recursively and get that answer back to our count. So basically, this is just doing a sort of DFS search through the topographic map. And so, let's see, I'll go over the get next step function here. It's pretty simple. Basically, it just takes in a tuple of the position, and then I didn't need to do this. I'm not sure why I did this here, but this is supposed to be the current value, like if it's as in like the current like altitude, right? So the possible steps, so this is just going up, down, left, or right, and then we iterate through these steps, and if it's not out of bounds, we're going to check if it's this is just basic math, just seeing like if it's 1 greater than our current, which means we can jump up to that point, right? And then we'll add that to our list of valid steps, and that's what we'll return. So it's going to get rid of all the positions that are either going to go out of bounds of the map or that are just too high for us to get to. I got this out of bounds function. I think it's pretty self-explanatory. It's just if it's within the bounds of the map, within the bounds of the matrix here, then it's good to go. Otherwise, we return false. And then the get trailheads and get trail ends are basically the same function. It's just iterating through this matrix, and if it's 0, we'll add that to our array that we declared here. I pretty much copy pasted it, but changed it from a 0 to a 9, because if it's a 0, then it's the beginning of the trail. If it's a 9, then it's the end. So yeah, that's how I did the first part, and this does work. I'll prove it to you right now. 36, and the answer here is 36. So that worked on the example input, and it did work on the input that it gave me too. Okay, so that was part 1. So for part 2, it's a little different. It wants another way of measuring the trailhead, where it's the number of distinct hiking trails that you can get from that trailhead. So the example that we're given is this. So as you can see, by isolating the different paths, it's a subtle difference, but it's important, is that there's actually 3 different ways to get to this trail here. And that would actually give it a score of 3, right? It's because there's 3 distinct ways to get to that final terminal point of 9. And then this trailhead here for this example, this one has a rating of 13 because there's 13 distinct ways to get to the 9. Right, you could go this way, or you could go this way, or you could go that way, or you could go to this way, that way, that way. Yeah. And so going based off the same example from before, so this one is a little trickier. So everything about this, oops, that's fine. So everything about my code here was pretty much the same, except I created this new function that called get all paths, and what it does is it gets all the paths from a certain position that's given to a target. And this one I had to sort of look around online and get some inspiration, but most of this I pretty much came up with on my own. I was debating between like, do I need to do this with like a breadth first search? I really had to brush up on my searching algorithms here, because this one's pretty interesting. It's kind of cool. It's almost like a backtracking depth first search. So so as you can see, I have a function defined within this function here. So what I'm doing is I have an array here of all the paths that I that I declared here, and then I call DFS with the start and target points with an empty path and a set, and the set is going to be our visited hash map, or just a regular set here. So just quickly going through this DFS, we're going to take this path that we're given, we're going to append our current given point that we're looking at to our path. And if our current point that we're looking at is the end, whatever target position we're looking for, we're going to append, and we can access this variable here because this function is defined within our sort of external function all paths here, right there. So we can refer to it like that. We're going to append you have to cast it to a list again, so it's like a new copy, and it's not just going to be changed every time you do this. That was something that also tripped me up. But yeah, so if we actually got to our target point, we're going to append this path to our array of paths here. Right. Okay. So we have that, and then we're gonna need to say that we've already visited this current point, and then we're going to look through all of the next possible steps that we can do from our current point. Just looking at all the neighbors, if you were thinking about a graph way. And if we haven't already been there, we're going to call DFS again on those neighbor points with that target value, the path that we have right now, and of course the visited set. And from there, we're going to just pop off that path, what we just added off the path, and then remove our current point so that we can, because we sort of have to like backtrack this, right? Because we didn't quite reach where we're looking for. And then be open to just different ways of getting to that target value. If you've ever written some backtracking algorithms before, It makes sense. It's kind of confusing. This is definitely something that really tripped me up on trying to solve this problem. Basically, we're just going through the paths and saying, did we get there? And it's like, okay, no, we're not there yet. Well, we got to look through all the neighbors and try again. And so we got to go back to that earlier position and just, you know, go through a different path and try it again. So yeah, I hope that makes sense. I probably didn't explain that very, very well, but yeah, I mean, this does work. So maybe I can just show you. See. So yeah, so this does work. We got the correct value. Let's see, maybe we can just. Okay, so this is pretty large here. So let's just do an example one. So print first one and then. So start from there and then let's see. Oops. Get all paths. Can't spell. At least I caught it. Oh. So yeah. So this is our first one that we're trying to get to, which is right here. And then that's our start position, and then the end position 0, 1 is this one. So what's happening here is that okay, we start there. We're going to add this position here, which is let's see, what would that be? That would be, this would be this one, right? So our next step is we're, for example, let's go here and see what happens there. And it's just going to go through each step. Boom, boom, 2, 3, add this, add this, add this, add this, add this, add this. And then it's pretty much going to hit a point where, okay, at this position here, 4, 4, where is it? Is that right? Yeah. So it's going to get to here, but it's like, you know, there's no way from this point to get to here. So that's not working. So it's going to pop off all the way back down to this point at 3, 2. See, 0, 1, 2, 3, 0, 1, 2, 3, and then come back to here. It's going to start all over from here and try to find another path back there. And so it's going to try this way, which is this one, and then from 2 to 1. Sorry, it's kind of confusing to do it this way. 0, 1, 2, 3, and then 0, 1, and then 1, 1. It's 2, 1. Here, let me do it like this, because that's just kind of confusing. Or I should probably do it after there. Or oh, what am I doing? Let's print out what it would actually be, the actual value. Let's go back to this first one here. Okay, so yeah, here we go. So it's going to start off from our first position here, which is just 0. And then it's going to pop onto all these next positions. And then here, like I said, it's going to get to 5. It's going to get to 5, 4, which is, I believe it should be this one, this 9, but that's not the target value we're looking. Well, it's the right value, but not the right position. So that's not going to work. So it's actually going to pop that off and try again with 3, 4. And then which I think is oh wait, oh sorry, I'm doing this wrong way. Which is this one. Okay, sorry. Gonna try this one, and then instead of that one, it'll try this one, which is also not correct. And then it'll try this one. It'll get to this point, which is that one, but that's also not going to work. So it's actually going to pop off all the way back to 3, 2 and try 3, 1 and 3, 1. Yeah, so it's all going back to 3, 1, which is the 6. Yeah, which is this value right here. And that was also not going to work. Or not that it's not going to work, it's just not quite the target value yet. So it's going to keep popping onto values that it can do. It's going to go to this 7 here, this 8, and then this 9 right there. Right, and so this is our path that we want, or just a valid path to get from 0, 2 to 0, 1. And since this was a valid path, we can add that to our list of all paths, that variable that we saw in the function here. Okay. So yeah, so hopefully that made more sense after I went through it like that. It definitely did work. Yeah, so it was cool to do something like this. I thought it was really interesting. The fact that this is sort of like a backtracking kind of DFS to get to all the valid paths from one position to another, to a target position. Yeah, so I had a lot of fun doing this. If you had a different way of approaching it, let me know in the comments. Or if you have any criticisms or feedback that you'd like to give me, please feel free to let me know. And yeah, thanks for watching.